Welcome everybody to the Convergence Data Classification Community Group meeting. Today's topic is the top 5 taxonomy best practices. Just a little background on for those of you that don't know, this classification community group meets about every 6 weeks. We do 30-minute webinars where we present a topic for about 15 minutes, and then we follow it up with a live question and answer, which we'll be doing at the end of our presentation today. So we'll be talking about the requirements for taxonomy. We'll be going through some best practice use cases, lessons learned, some demonstrations, and then we'll have a live Q&A. The folks that will be presenting today, starting with myself, Richard Turner, followed by John Fair, Megan Proctor, Victor Ruiz. We all work for Convergence Data. We've been doing parts classification for over 18 years, and we work with various PLM systems. We are partners with Siemens and PTC, and we also have our community group. And if you want more information on our community group, if you go to our website, convergencedata.com, you'll see there's a tab for the community group, and then from there you can access past webinars and blogs and any other best practices you're interested in. There's lots of information and resources there, so please check it out. So we actually have 10 taxonomy best practices. We're just going to present the top 5 today, but later on we will make available all 10 in the future. So today we're going to talk about number 1, flexibility in managing category structure. Practice number 2 in taxonomies, supporting both searching and creating new parts. Number 3, the need to be able to support multiple ways of searching. We'll walk through multiple ways of how you can use a taxonomy for searching. And then also the importance, if you're creating a taxonomy and putting it into a system like a PLM system, we'll walk through some use cases of how that all works. And then lastly, we'll talk about supporting relationships as far as it impacts a taxonomy. So the first best practice for taxonomy will be presented by Megan, and she'll be talking about having a flexible structure so it can handle changes that may occur down the road.
Thank you, Richard. Today we're going to talk about the structure flexibility with changes. We want the structure to be flexible with any changes that may occur after the initial taxonomy setup. Customers will sometimes build out a classification structure without or before putting data against it, but find that once the data is enriched, the structure may call for a change. This is normal and easy to handle by performing a simple prune and graft. A prune and graft is essentially cut and pasting the category and associated data to another area or section of the taxonomy. This process or procedure still ensures that the category, its attributes, values, and properties are protected and untouched, simply just moved to another area or section in the taxonomy. When a user is assigning attributes to a category, it's important to pay attention to what we refer to as common attributes. This example on the bottom left shows a leaf node, clench bolt, that has attributes common with other leaf nodes under bolts, such as bolt type, bolt material grade, and bolt finish. Since these are shared across all of the bolt storage classes, moving or assigning these common attributes to the parent or abstract class is the right thing to do, as shown in the top left image. These attributes will share one global LOV or list of values, also known as an allowed values list, as opposed to each individual storage class having repetitive LOVs. Some PLM systems support searching at an abstract or parent level. A taxonomy that supports inheritance aids in generating the best search results for these PLM systems at that level.
Thank you, Megan. The next best practice we're going to talk about is a taxonomy needs to be able to support both searching for parts as well as creating new parts. And I'll be presenting this particular best practice. So let's start with searching. In this screenshot right here, you may be familiar with this. Anyone who's gone to Grainger or McMaster Carr, which most engineers do when they can't find a part locally, which is common when their data is not very good, they are exposed to different ways to support different ways to search for parts using classification. So one way is they can use attribute filters. You see on the left here, when they get to a particular storage class or leaf class, they can be exposed to key attributes that will quickly allow them to find the item that they're most interested in. So you want to make sure the most important attributes for searching, and not all attributes are important for searching, are listed first, and they're in the correct order. So right here we've got thread size, length, and drive type, and this is for a cap screw. And you can start searching on thread size, then length, then drive type. Then most likely they're going to be very close to the exact fastener they're trying to find if you follow this correct order. Another way that they could look for these cap screws is by a category search. So if you've done a really good job, and you can see in the screenshot we show different category names for screws. We've got cap screws, machine screws, set screws as examples. If you've done a good job naming your categories, they should be able to fairly quickly get to the exact category without really having to understand how the whole classification structure is put together, because most of the search users will not have that knowledge, and they just want to be able to easily find things without having the knowledge of how the taxonomy works. So you want to make sure you do a good job with your category names. So just to summarize, you want to make sure you have your attributes in the right order, and the data for those attributes, like if it's numeric attribute like length, that you're using units of measure, and that the values are displayed against one unit of measure in an ascending order versus a miscellaneous list, or versus an alpha sort, which would not have the numbers in the right order. That would only confuse people and make it more difficult for searching. So that's important to consider as your units of measure, and also to make sure you have appropriate category names. So that same taxonomy that supports searching also needs to support creating new parts. So you search for a part, and unfortunately, you've not been able to find a part. We want to make it very easy for a user to create a new part, but we also want to, most importantly, make sure that the new part they create is created following best practices for classification, and you're creating a part that can easily be reused in the future. So you want to make sure that the attribute values are displayed in an order to help them find an existing part, and if they don't find a part, they can start entering values for the new part. And one of the things that we recommend is they use an allowed values list versus typing the information in and potentially misspelling or providing another way to describe the same thing. That would only pollute your classification data. We recommend you have an allowed values list, or an LOV list, list of values, whatever you want to call it, present, and then they can just select values versus typing them in. So that's really important, and that'll help institute and maintain your data governance strategy, keeping your data clean when you're creating new parts. So that's something that's really important when creating new parts. And also the display order is important. You want to make sure you have the right attributes up front, similar to searching, to make it easy to get a balance of both those requirements, so that it's easy for someone to create a new part, most important attributes first, and that you have proper guidelines in place to make sure that there's data governance in place, the right people are approving these parts, and you've got things like allowed values list present to ensure that your data is clean. All right, the next best practice, number 3, Megan will be presenting, and it's going to be talking about how a taxonomy also needs to be able to support more than one way of searching.
Thank you again, Richard. As Richard mentioned, the taxonomy needs to support multiple ways of searching, and we actually have 4 different ways that I'm going to go over. A classification search, the first search we're going to talk about, is most helpful when the user knows most of or the full category name. For example, if I search compressor, the results generated would return as all categories with compressor in the name. For example, reciprocating compressor, scroll compressor, or the compressor abstract or parent category itself. A part search searches on an exact part number. A keyword search functions as a Google-like search using keywords to generate all items with that word in the name. Staying along the lines of the compressor example, I could search compressor 5 horsepower and narrow down anything with those keywords in it to best locate my search item. Lastly is an image search option. Engineers typically visit websites such as Grainger and will search by image until they find the item they are familiar with. This search is useful when a user is not familiar with the exact part number or exact category it may be in.
Thank you, Megan. So the next best practice we have, best practice number 4 for taxonomies. John will be presenting, and he'll be talking about how to basically understand the target system you're going to be deploying this taxonomy to. In his example, it's going to be a PLM system.
Thanks, Richard. So as you'll see in the screenshot, we've got some information there in one of the PLM systems we've worked with before. To Megan's point earlier, we have multiple different classes of data, including some parent classes or higher level classes, abstract classes such as fasteners, nuts, rivets, and screws. And then we have some lower level leaf classes such as jam nut, lock nut, etc., kind of on display there. One of the things that is important when you're creating your taxonomy is understanding how these different classes will work with the system that you're using. Some systems, like the one we have here, support what are called abstract classes, and that means that your parent classes can have common attributes that are inherited on every single one of those child classes. So on the right-hand side of our image, you see that finish, height, material, type, thread type, and material grade are all on the abstract parent class of nuts, which means every single one of those nut types below will have those attributes. Now, other systems may not have that capability, and each leaf class may have to individually have its attributes defined. You may need to have a hex nut finish or a spring nut finish as your attribute name in order to determine what information you're actually looking at and to helpfully filter down your list of values or LOVs. Knowing how the system that you're using imports and examines this data will help you determine how to set up your structure in the most effective way.
Thank you, John. The last best practice that we'll talk about today will be presented by Victor. It's best practice number 5, and he's going to be talking about how to support relationships with your taxonomy.
Thank you, Richard. Relationship data allow us to map, group, or attach bundles or parts, lists for products, to alternate parts, preferred parts, accessories, images, drawings, commercial data, files, programs, and more. The most typical type of relationship data that most customers take advantage of is the one-to-many relationship. This is mostly used to relate a part or a bundle to alternate parts or preferred parts. The one-to-many relationship is a record that relates to none, one, or many records in that related part, meaning that a record might contain 0 records or more. In other words, relationship data allows you to relate an item to multiple items. For example, in the first screenshot, you can see that this is an example of a bundle, and it demonstrates how a bundle can contain multiple alternate parts, and where this is also can be across store multiple bundles. So relationship data does not only allow you to display all items stored in a bundle, but it also allows you to click on every single part where all attribute data will be shown for each single part. And in the second screenshot, you can see how you can map or attach document or files to an item. So in this case, you can see the part with all the attribute data, and you can also see that there is a link that contains a PDF file. And if you click on that link, you can download that PDF file to your computer.